Hi everyone! In this video we're going to learn how to solve right triangles. In a right triangle, if we know two measurements, at least one of which is the side length, then we can find all other side and angles of the triangle. For that we'll need to use right triangle trigonometry and a calculator. And in general, to solve a triangle is to find the measures of all the angles and sides of the triangle. Here's an example. We need to solve the right triangle ABC if A equals 63 degrees and B equals 12 inches. The very first and very important step that I have to do when you're solving the right triangle is to make a labeled sketch. Here's the right triangle. It's common to label the right angle with letter C. Then I place A here and B over here, so it doesn't matter where A and B go. And the way we usually label sides is by using the lowercase letters corresponding to the opposite angles. So for example, hypotenuse I'm going to label with lowercase c, since that's the side opposite of angle C. This leg I'm going to label with A, since it's opposite of angle A, and then base is going to be side B, lowercase b. So what we're given is that angle A is 63 degrees, so I'll make sure to label that. And then side B is 12 inches. So to solve this right triangle, we need to find all the remaining angles and sides. So that means that we need to find angle B. Now, angle C we do know, right? It's 90 degrees. We need to find side A and then side C. Overall, it doesn't matter which one you start with. I think I'll just go in this order. So in step 1, I'm going to find angle B. In this case, I don't really need to use trigonometry to find angle B, since I already know two angles out of 3 in this triangle. Then I can simply find angle B by adding two known angles, which is 90 and 63. That's going to be 153 degrees. And subtracting that from 180, because I know that sum of all three angles in any triangle equals 180 degrees. Equals 180 minus 153. That is 27 degrees. In step 2, I'm going to find side A. And that's where I have to use the triangle trigonometry. So if I look at the given angle, angle A, and the side that was also given, side B 12 inches, I can see that this side is adjacent to the given angle. And then side A that I need to find is the opposite side. Now I have to think which trigonometric function involves the opposite side and adjacent side. Well, that is tangent function. So tangent of angle A is the opposite side over the adjacent side. And in my example, well, angle A that I'm working with is 63-degree angle. And the opposite side is side A. That's the one I need to find. Since I don't know it, I'll just write it as A. And the adjacent side is side B. And I'm given that it measures 12 inches. So it's A over 12. Now, before I get my calculator, I'm first going to isolate what I need to find, which is A. So I want to get it by itself. How do I get A by itself? Well, I'll just need to multiply by 12 on each side of this equation. So if I multiply by 12 on the right-hand side, that cancels the denominator. And of course, I need to multiply by 12 on the left to keep the equation balanced. So from here, I can see that side A equals 12 times tangent of 63-degree angle. And that's what I'm going to input in the calculator. Okay, so I'm going to do 12 times, tangent button is here, tangent of 63. Now when I'm using the calculator, I always need to make sure that I'm entering the correct units of the angle measure, so degrees in this case. Well, that little D at the top confirms that I'm entering degrees. If it said R, it means that I would be entering radians, which is not what I have in my problem, and I would have to change it. Now on this particular calculator, to go from radians to degrees and back, I press Shift, then Set Up, and then here I choose or I press either 3 or 4, depending on what units I need. So for degrees, I have to press 3. Okay, so everything looks good. Now I just press Enter, and I see what side A equals to. I did a note here, so let's say we need to round answers to the nearest tenth. So that's 1 digit after the decimal point. Okay, so that 1 digit is 5, but since 5 follows it, I have to round up, so it's going to be 23.6 inches. And since it's approximation, I'm going to use wiggly equal sign. 23.6 inches. Okay, so I added my answer here and on the sketch. And what we have left to find is side C. Technically, we have options. What are the options? Since we already know 2 sides in that right triangle, we can always find the third one using the Pythagorean theorem. Okay, so that's technically option number 1. What's the other option? Well, to use the triangle trigonometry again. To help us decide which option to choose, I'd like to make the following note. When you're solving triangles or doing application problems involving right triangles, to maintain accuracy, always use given information as much as possible. That means that it would be better to find the remaining side C by using given angle A and given side B. So that's where we'll have to use triangle trigonometry. Why the idea of using the Pythagorean theorem here is not that good? Well, because in order to use the Pythagorean theorem, we'll have to use the given side, side B, which equals 12 inches, and the side that we found in step 2, side A. But remember, this is not the exact length of side A, it's approximation. Well, it's good approximation, but still, it's not the exact. Because we had to round, it contains a small error. And that's why we'd rather not use it in the further computations if we can avoid it. Okay, so let's perform step 3. Let's find C using triangle trigonometry. Now, the given side is the adjacent side for the given angle. But what is side C? Well, that is the hypotenuse. Which definition of the geometric function involves adjacent side and hypotenuse? Well, that is cosine function. We know that cosine of angle A is the adjacent side over hypotenuse. Now, angle A is 63 degrees, so cosine of 63 degree angle is adjacent side is 12, and hypotenuse is C, the unknown side. Same as in step 2, first I'd like to get C, the unknown side, by itself. This way I'll have expression ready to be entered in the calculator. First, to clear that fraction on the right hand side, I'm going to multiply by C on the right and on the left. That cancels C in the denominator. So far I have C times cosine of 63 degree angle equals 12. And now to get C by itself, I'll have to divide by cosine. I'll have to divide by cosine of 63 degree angle on the left side. That cancels cosine. And on the right hand side. So side C will be computed by taking 12 and dividing it by cosine of 63 degree angle. So 12, divide, then cosine, and then 63. Again, I confirm that I'm entering degrees. That looks good. Equals, and again, we're going to round to the nearest tenth, so it's 1 digit after decimal point, so it's 4. Since it's followed by 3, I'm going to round down, so it's going to be 26.4, approximately 26.4 inches. So I'm going to add that answer to my list, 26.4 inches. And I added to my sketch just to complete the picture, 26.4 inches. So we solved the right triangle. We now know all angles of this right triangle, and we know all sides of this triangle. One trick that you always can use at the end, just to catch some mistakes, is to confirm that the longest side is opposite the largest angle, and that's true. 90-degree angle is the largest one, and 26.4 is the longest side. The shortest side is always opposite the smallest angle, so 12-inch side is opposite of 27-degree angle, that's the smallest one. And here we have middle angle and the middle side. And as I said, that helps to catch some mistakes.